Okay, so we need to separate this. I need to put all my y things on one side and all my x things on the other. So right now, I know that what I could do is multiply by dx, right? But I still need to get this y to the other side. And since this y is multiplying x squared, the only way to move it would be to divide. So that's going to look like dy over y equals x squared dx, which looks kind of funny. And what I would prefer to see is the dy and the y in their own separate things. So I'm going to split it, and I'm going to say instead of dy over y, I'm going to call it 1 over y dy and x squared dx. Okay, and the reason for that is because I know my next move is going to be to integrate, and it would be confusing to integrate dy over y. Instead, if I split it up into their own two little things, then when I integrate, I'm just integrating 1 over y. And so to do that, the antiderivative of 1 over y would be ln. And it would actually be ln absolute value of y. And I'll explain that in a second. And then x squared, that would be 1/3 x to the third if I take the antiderivative. The absolute value is needed because remember that ln only operates if what you plug into it is greater than 0. And so I don't know what y is equal to, but in order for this to work, y would have to be positive. So we use the absolute values to sort of take care of that that restriction on the domain. Okay. Remember, your C's really don't need to be separated. You could just say C on one side is good enough. And usually I put it on the right with the X's because I'm trying to get Y alone over here. So I need everything to be like moved out of the way. Okay, this one's fun because we've got ln. Here we go. Is there a way to get y out of this equation? Yes. It is called the logarithm song. Do you remember the logarithm song? Take the base and make it the base. So the base of ln is e. So you would take the base, make it the base, take the other side and make it the exponent, which, oh my. So all of this would be the exponent, okay, equals the inside, and the inside is absolute value of y. So that's just ln rules that we worked on earlier this year and last year. Now, I'm not done because I need to do a couple things. One, I need to clean up this left side. Two, I need to take care of the absolute value thing. I'm going to show you how to clean up the e to the power of all that stuff first. Okay, so what you can do is you can actually separate this so that your exponent isn't so complicated. Here's how that works. This is being done using exponent rules, okay? So this is technically the exact same thing as having 1/3 x to the third added to c, because remember, if you have like bases, you would add your exponents if they're being multiplied. So I am just undoing and kind of going backwards a step to say that adding exponents is the same as multiplying things with two like bases. And then I'm going to kind of stop and think, and we're going to use some common number sense here. What does e to the c really mean? Okay, what's e? Hold on, my pen's not working. Okay, I think we're back. So what is e? E is just a number, right? It's 2.718 something something something. What's c? C is just a number, so you're raising it to some power. So if you take just some number that is a fixed value and some other number that's a fixed value, and you take that one and raise it to the other power, you're just going to get some number, right? And I just want you to kind of remember that C is a constant. E is a constant. So e to the C together would also be a constant. So this is where we can simplify things, and we can, instead of saying e to the C and making it all messy looking, we can introduce another value, just one letter, and say that that's representative of e to the C. Okay, so I'm going to make a change, and I'm going to say e to the C is some constant value, and I'm going to rewrite my equation like this. I'm going to put k in place of that, e to the C, and I'm actually going to move it to the front just to make it look a little bit cleaner. Okay, last step is to take care of the absolute value. Absolute value just means that you have positives and negatives as partial solutions for this. So you're going to undo that by just putting plus or minus on the other side of your equation. And that would be your solution to this differential equation. So obviously that one is more complicated because of the separation step, and also because you're dealing with ln. I think I have one more here, like this. Yeah, I got one more. Okay, so solve again. You'll notice a couple things are different. We have dy dt instead. So remember that if you have dy dt, that means you're taking the derivative of y with respect to t, okay? So essentially y and t are the variables in this equation. Anything else is a constant. So in this case, k is a constant value. It would be like if k was a 5, okay? If k was a 5, or 10 or 7,000, whatever. K is just something, some number. All right, we do need to separate. I basically, to separate this time, just need to move the y to the other side and move dt to the right. So to move the y, we're in that situation again where we have to divide by y, which would make it a 1 over y over there on the left side. And then k is a constant, and I'm moving dt over to the right with it. Integrate. Okay, antiderivative of 1 over y is ln, and we need that absolute value there again. All right, challenge question. What's the antiderivative of k? To answer this, I'm going to ask you, what would be the antiderivative of 6? Let's say dx. That would be 6x, right? Antiderivative of 6 would be 6x. So what's the antiderivative of k with respect to t? It would be kt, okay? Or you could maybe look at this one more time. What would be the derivative of 6 with respect to t? It would be 6t, right? Well, we don't have 6's. We just have a k. So our answer is going to say k is some number, and t would then be attached to it. All right, we still got to do a little bit of algebra now. The calculus part is done. Algebra next. So we're going to say I need to solve for y, so I got to get it out of this logarithm, and I'm going to use the logarithm song. So take the base, make it the base. Take the other side, make it the exponent. Take the inside, make it the other side. So this is following exactly where we were in the last example. I'm going to flip it. Okay, before I do anything with the absolute values, I'm going to do that exponent rule trick again, and I'm going to separate the sum. And I'm going to say this would be the same as e to the kt times e to the c. And I'm going to represent e to the c as some constant value. You're typically going to see k, or sometimes a, sometimes d. It changes a little bit, but it really doesn't matter what letter you pick, to be quite honest, just as long as you pick something. So I'm going to take that k value and I'm going to move it. Actually, you know what? I can't use k. Anybody catch that? K is already in the problem. I can't use k because then that would be assuming that they're the same. and that's not necessarily true. So let's use A. We'll use something different. So I'm going to move this A value to the front, and then I have AE to the KT. And then what was the last step again? Like, how do we get rid of that absolute value? We put a plus or a minus. Okay, one other quick discussion point. Is the plus or minus that important? Because what does A represent? A represents a constant. Constants can be literally anything. So us putting a plus or minus in the front is a little bit like unnecessary because A represents literally any number. So why would you put plus or minus when A could represent literally any number? So maybe y equals a e to the kt would be better. So this is okay answer up here, but a better answer would be just to recognize that the plus or minus is sort of arbitrary. Okay. Again, I know that you guys like steps, so here are the steps for you step people. I only did one example like this, so I wanted to break it down for you to find a particular solution with an initial condition. This is where you're like plugging numbers in. You are going to integrate like we've been doing. You're going to find the value of y, and then you're going to plug the point that's given. This would be like your initial condition. To find your constant of variation, and then you just plug your constant of variation back into the answer that you already got. All right, we're going to do one more like that because that's a super important skill for us. Okay, so it says, for the differential equation 3x plus 2y times y prime equals 0, verify that 3x squared plus 2y squared equals c is a solution, and find the particular solution that satisfies the initial condition y equals 3 when x equals -2. Okay. So what I'm thinking that we could do this a couple different ways. What I did at the beginning of the lesson is I took an equation, when we did this verifying thing, I took the equation that was given and I just plugged it in to the differential equation. But that's kind of difficult to do here because this equation's not solved for x or for y or for anything. So it make it a little messy to approach it that way. I'm thinking what I'm going to do instead is I'm going to just solve this differential equation like I've been showing you on the last couple of examples. So I'm going to do, the step process that we've been working on and see where that takes me. So the first step is to do what, right? Y prime as dy dx. And then the goal is put all the y things on one side and all the x things on the other side. So okay, this one's very different than before. I'm going to have to subtract 3x. Okay, subtract 3x. And then I need dx to be over here, which I can multiply by dx. I guess this is going to be okay. So I can multiply by dx. Okay, cool. So I've got everything separated. Now let's antiderive. This would be 2y squared over 2, so it would just be y squared. And then negative, let's see, x squared over 2, so it would be negative 3 over 2 x squared plus c. Okay, looking good. This is supposed to be the same as this equation if we're verifying. It doesn't look the same to me. Some things I'm noticing is that we have a fraction in our answer and there's no fraction up there. So I'm going to try to algebra through this a little bit. I think what we could do is we could get rid of the fraction by multiplying the whole equation by 2. which would give me